We'll move on to 2.2. Power functions with modeling. So we're going to do power functions, and we're also going to do some modelings using power functions, okay? One of the biggest problems or questions that you guys have is, so a power function is a function that looks like this. To the n, okay? Where, okay, so this is the blue box definition on page 174, where k is just a constant, or we call the constant of variation, constant of proportion. And, oh, this is A, which is a power here, okay? Right. That's it. So this is a power function, not to be confused with this. Okay, this is an exponential function. This is a power function. Look, notice where the x is. If the x is in the exponent, it's an exponent function, it's an exponential function. So y is equal to e to the x would be an exponential function. Whereas what we're learning today, where the x is in the base, okay, that is called a power function, okay? So this is a power function. This is what we're going to talk about today, okay? So example number 1, writing a power function formula. From empirical evidence in the laws of physics, there has been found that the period of t for the full swing of a pendulum is blah, 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 is the, okay? So for you guys who were in my engineering class, we just did this, okay? So y is equal to, right? It was, what does it say? It says the period of time t, so we'll call this period, okay? Full swing of the pendulum varies as the square root of the pendulum's length, the square root of the pendulum's length, right? Provided that the swing is small relative to the length of the pendulum. So express this in, so it's going to look like this, right? So you're going to have some constant times L to the 1/2 power. Okay, all right. Now let's go ahead and look at example number 2. State the power and constant of variation for the function. So example number 2 says state the power and constant of variation. So A is this. This is A. So it's equal to x to the 1/3 power. So it's the 1/3 power with a constant of variation of 1, right? And there's a 1 here that you're not seeing. And then in B, we have y is equal to 1/x², which can be rewritten as that. And again, there's a constant of variation 1 that you're not seeing here, right? So the constant of variation is 1. The power is -2. And for A, the constant of variation was 1. The power is 1/3. Okay. Okay, so let's go to the bottom of page 175. And we kind of briefly talked about this when we were talking about polynomials. We said there was a thing called monomials, and this is what we're talking about. A monomial function is a function where y is equal to k to x to the nth power, where n is your integers, right? It's a positive integer, right? Okay, that's a monomial function. Okay. So then there's the cubing function. So y is equal to x². Y is equal to x² looks like what? Y is equal to x² looks like this. It's a parabola, right? So if I had x², it's going to look like that. If I wanted to draw the cubing function, it's going to look like that, right? If I look at x to the fourth, it's going to look like, I'm going to draw it right on top. Well, it's going to look like this. I can do better than that. It's going to look like this. Okay, this is x to the fourth right here. Okay. Okay, so in example number 3, it says, describe how to obtain the graph of the given function from the same power and sketch the, okay. So we have, example number 3, the function is y is equal to 2x cubed. So how do we obtain this? We obtain this from y is equal to x cubed. So we start with an y is equal to x cubed function. And since this is divided by 2, that means that we're vertically stretching it by 2, right? We're vertically stretching it by 2. Okay. And then on B, we have what? So this is A. And on B, we have y is equal to negative 2/3 x to the fourth. Okay. So we're going to start from this function. We're going to start from this function. Okay, and then we're going to divide this by 2/3. Okay, that takes care of the 2/3 part. And then you have the negative here, right? Okay, so a lot of you kind of missed this. Some of not a lot of you. Some of you missed this on the test, the last test. When you have a negative here, okay, this negative does not go down here with you. You cannot vertically stretch or horizontally stretch or whatever anything by a negative number. That number always has to be positive, okay? So 2/3 here, and then you have the negative over here, right? And the negative still is available here, okay? So how do you take care, where do you get the negative from? The negative is when you go ahead and go like this, right? So wherever y was, you put negative y, which means that you have reflected it across the x-axis, okay? So that's what that negative means. That's a reflection, okay? So depending on where that is, you have to find out what's going on there, okay? So you look at it, it says y is vertically shrinking the graph of the original y equal to x to the fourth by 2/3 and then reflecting across the x-axis. Okay, like I said, okay, that's where that negative comes from. Okay, so that's that. Let's move on. Graphs of power functions. The graphs of power functions are located. So let's look at A there. A is the graphs of y to k to the k times a to the x to the a power for x is greater than 0. A is when k is equal to greater than 0. B is when k is less than 0. So let's take a look at that there. Basically what's going on is this. So you have y is equal to k x to the a, right? X to the 8th power, a power, okay? So when x equals to, when a is greater than 1, this is going to look like this, okay? When a is equal to 1, obviously because y is equal to kx, so it's going to look like a straight line, right? So this is going to be when a is equal to 0. This is going to be when a is greater than 1. And when a is less than 1, what happens is it's going to go like this, right? So what does that mean? In other words, when a is equal to 1/2. In other words, y is equal to square root of x, right? This is the square root of x graph, right? Okay, it's going to look like this, okay? Okay. So this all happens when k is greater than 0, right? So for this to be on this plane, so this is going to be when k is greater than 0. If k is less than 0, if k is a negative number, then you would just go ahead and flop it on down into here, right? And that graph is shown on figure 2.14, the bottom one. As you can see, it's flopped over down here. Okay. Okay, let's go ahead and do example number 4. Example number 4 then. Example number 4. State the values of the constants k and a. Describe the portion of the curve that lies in quadrant 1 or quadrant 4. Determine where f is even or odd or undefined for x is less than 0. Okay, so we have a, y is equal to 2, x to the negative third. Okay, all right, so k is 2, obviously here, right? K is equal to 2. The power is negative 3. Okay, so what's that going to look like? So do we actually have to, okay, so what are we doing here? What else are we going to determine if it is even or odd or whatever, right? The function is odd because it has this, right? Because this is basically, right? And y is equal to this is an odd function. Okay, so this is an odd function. So this function itself is going to be odd also. And if you graph it out, you can see that it's symmetric across the origin. Okay. What else do I need to know? We talked about that. Describe the rest of the curve. Okay, there really isn't anything much more that we need to talk about. Okay. Let's look at B. Y is equal to negative 0.4 x to the 1/2. Okay. So this is neither odd nor even, right? Because you have a funky one here, right? A little funny looking thing here. K is going to be the constant, right? The constant is 0.4, negative 0.4, right? Negative 0.4, which means that it's going to be in this quadrant down here. Okay, all right. So it's going, okay, so if you draw it, it's going to look like this. Okay, it's going to look down like this. Let's get rid of that. You don't need that. So this is what the function is going to look like. It's going to look like this. Okay, so it's in the 4th quadrant there, right? And so it's neither odd nor even, so it's nothing like that. Okay. So that's good. And let's go to number C. We have negative. By the way, don't be too afraid when you see this, because let's look at this function. The function looks like this. The function, let's just forget about this. Let's go ahead and just look at this. This is the same as x to the 3/2. Okay, so basically this is what? This is x 1/2, right? So basically it is the square root of x to the 3rd. Okay? It looks kind of daunting, this. If you think about this, it's not too bad. Okay? Okay, so that's that. And there's a third one, y is equal to, this is C, negative x to the 0.4, same thing here. It's neither even nor odd, right? It's going to be in the 4th quadrant, right? As a matter of fact, if you draw it, it's going to look like this. It's going to look like that. Okay. So actually, this is an even function. Yeah, it looks like it's an even function because it's symmetric across the y-axis, right? Okay. And what else do we have? That's it. All right, we're good. Okay, so let's go ahead and stop right here for the first half. And then we will come back and finish it off. We'll do some modeling, okay?